So we're applying the function with base E. So we have Newton laws of cooling relates temperatures of an object over time in relation to its initial temperature. So we have some sort of initial temperature of an object and the temperature of the surroundings. So those two temperatures, and the temperature in degrees in Fahrenheit of a bowl of soup over time is modeled by this function. So T sub 0 is the initial temperature, T sub 0, and then the temperature of the room is T sub A. So this one's T sub A, or the ambient temperature of the room, and is in minutes. So we want to find the temperature of the soup that is initially 200 degrees, so that'd be T sub 0, in a room that is 72 degrees Fahrenheit, so that's T sub A, after 30 minutes. So that means our little t, that's time, is equal to 30. And so we're just going to use this formula here, enter it in, and then find out what the temperature is after 30 minutes. So after a certain time, T sub A is 72 plus T sub O, which is 200, minus T sub A, so that's 72 again, e raised to a negative 0.03 t times 30. And you can enter all this into your calculator just like this, and it should be all fine. Just make sure you put parentheses where you are. When you hit this E button, it automatically either put it as an exponent or it might put it as a parenthesis, so then you got to end this second parenthesis out there. But all this should be fine. You can type it in, you can push enter, and it's approximately, I believe, 121, so 121 degrees. So it's a little cooled down, right? So what do you kind of want your temperature of soup to be? So here's a different question. So what if we want the soup to at least be 180 degrees Fahrenheit, right? So we want our soup to be warm, we want to feel good eating soup. So we want this amount, the initial at the end, to be over 180 at least, right? So at least it is 180, so it can be 180 or smaller than that, right? Or that amount could be bigger than that because we want it at least 180, but it could be more. So we write that at least symbol, or equal to, and then our T sub A is still 72 degrees, and our temperature of initial is still 200, and minus 72 again, and then E raised to the negative 0.03 T2 times time is T. And this, we want to find out how long will it take the soup to get down to at least 180 degrees. Make sure the soup is at least 180 degrees when it's served. And so we're just solving for t here. So t is in the exponent. So again, we want to get that exponent, isolate that exponent, right? So we need to get rid of all this stuff, right? But this is being multiplied, right? So I can't just add 72. So first I got to get, or this 200, right? So this one I got to kind of wait on, but I can get rid of this 72 right off the bat. So that'd be what, 108. And we can treat this as an equal sign for now. And this is being multiplied, correct, by E. So that means we need to get rid of it by dividing. So we're going to divide by that, or we can actually just perform that operation, right? So that's 100 and what? 68. So divide by 168. And so again, we can perform that operation. So e to the negative 0.032 times t, whatever this is. And that is not, this is actually 128, correct? So some of you guys might correct me on that because that doesn't even seem possible. We'll erase that. That's 128. If I can easily subtract. Now, that might be rounded, so you might want to just keep that as a fraction, right? Because if you round it there, you always want to wait to round to the end. Okay, so now I can take the natural log, right? Because now I'm just solving. So then I take the natural log of both sides. So I just keep that as a fraction, right? And then ln of e, this just moves out front. And so that's just being times by ln of e when ln of e equals 1. So this just becomes negative 0.032 times t equals whatever the ln of 108 divided by 128 is. And I like to keep it in there so then I don't round until the very end. And then to get rid of multiplying by 0.032, negative 0.032, I just divide by negative 0.032. And so I just type all this into my calculator. So how I might do it on calculators in the classroom is I might type ln, it'll bring up a parenthesis, and then I hit alpha link to put in the fraction bar. So it does a fraction bar for me. I can put in 108, then I can arrow down, put in 128, arrow over, close that parenthesis, and then I might hit alpha link again, or actually maybe to begin with I might hit alpha link, and then it'll give me a fraction, and this is on the top. And then when I'm up here in the ln, I need to make sure I hit alpha link again, and then arrow down and put in this negative 0.032. Or I could enter this in first, hit enter, and then divide by negative 0.032, and that would give you my t, which is approximately 5.3. So it would be about 5.3 minutes before it cools at least 180 degrees. Okay, and then what if you had a different question? Suppose the restaurant manager wants to increase the temperature of the restaurant. So cold outside, so he wants to put it at 75 degrees. So his initial would be at T sub 0 would be 75. Still wants the soup, serve the soup while it's hot, 180 degrees or warmer, right? And then what temperature will the soup have to be if the initial taken off the heat source? Okay, so we're going to do it for 7 minutes. So that means that's our T. And so still 180 less than or equal to. Now our temperature of the room is 75, but we don't know our initial temperature. That's what we want to find out if we want to serve it at least 7 minutes to serve it. 75 and then E. But we know now that it is 7 here, 7 minutes. So now a little bit maybe different kind of work, because now we're not solving for the exponent anymore. Right, so now we can go ahead and subtract 75, and now it's just 105. I can get that right. And then here, our initial temperature is what we're trying to find. That's being multiplied by E raised to negative 0.032 times 7. Right, and I could times that, but I don't know off the top of my head. But here this is multiplication, so I need to get rid of this, right? So I need to divide by whatever that E to the whatever this is. So I divide by that. And again, I can wait to the very end to do it. And so now we have less than or equal to. Still haven't divided by negative, so I'm not going to switch that inequality yet. So I have 105 divided by E raised to negative 0.0732 times 7, which you could do that because that comes out nice. It's not, doesn't repeat itself. That's why I usually don't round yet. If it ever keeps on going forever, I usually leave it in there. And then T sub 0 minus 75. So then I can add 75 to both sides. So I have 105 over E raised to negative 0.032 times 7, and then plus 75. It's less than or equal to T sub 0. So what you can do here on your calculator is you could do the alpha link to get that fraction bar. Some different calculators just have a fraction bar. And so then it'll bring up a fraction bar. You can put 105, and then on the bottom you hit E, and it automatically either does a parenthesis or brings up something, an exponent. So you can do negative 0.032, and then put the 7 in parentheses, and that's going to multiply it for you, and then arrow over, so then you're out of that fraction, and now you're on top, and you can just add 75, and then you can go ahead and hit enter. And then so then you have T sub 0 is greater than or equal to approximately 206.4 degrees Fahrenheit. So there you go. And those are different ways that you could apply this.